Math 3, Unit 8, Section 4. Today we're talking about solving trig equations. Prior to this, we talked about creating a unit circle, so if you haven't watched that video, you're going to want to watch that one. One thing to remember about our sine and cosines are like when they're positive and negative. That's going to be helpful, okay? And so we know that sine is dealing with your y values. And so if this is your coordinate plane here, okay, we know that going right and left is x, and specifically on the x-axis going to the right is positive, and down and left is negative, correct? Up and down is our y-axis, and specifically going up is positive and going down is negative. And so when we look at these quadrants, we are able to figure out when sine is positive or negative. So in this quadrant, in quadrant 1, sine is positive. In quadrant 2, sine is positive, right? Y is still going up in quadrant 2. Okay? But in quadrant 3, it's negative, and in quadrant 4, it's negative. Okay, cosine is dealing with our x values. Okay? And I'm not going to write out all these positives and negatives around it here again. But x is what in quadrant 1? Positive. In quadrant 2, it's negative. 3, it's negative. And 4, it's positive. Okay, tangent is when you're dealing with like your y value over your x value. Okay? So in quadrant 1, you're having a positive over a positive, which makes a positive. In quadrant 2, you have a positive over a negative, which makes a negative. In quadrant 3, it's a negative over a negative, which is a positive. And then in quadrant 4, it's a negative over a positive, which is a negative. Okay. So based on that information, they want us to identify all possible quadrants in which a terminating ray for these angles could lie. So they're saying right here, sine, which is y, is less than 0. Meaning what? Sine would be what? Negative. Negative values are less than 0. And so where is sine negative? Which quadrants? Very good. Quadrant 3 and quadrant 4. That would be my answers. Okay, the second one. Tangent is greater than 0. And that one is dealing, remember, with our y over x is greater than 0, which means that tangent is what? Positive. Okay, which quadrants is tangent positive in? 1 and 3. This right here is saying sine squared, okay? Now, what that means is that whenever we square something, if I squared a positive number, it would become positive. If I square a negative number, it would become positive, right? A negative times a negative is a positive. So what this one is actually saying is that sine could actually be all 4. Yeah, it could be positive or negative, right? So on this one, we're dealing with positive or negative and greater than 0. Whenever you square these, right, a positive or negative number, you square it, it always ends up becoming a positive, okay? So therefore, all 4 quadrants would work. Okay, because in here, if you have a positive and you square it, you get a positive. In here, if you get a negative and square it, you would get a positive. So no matter what you use will work. Okay, so you can just put all 4 quadrants, or you could list them all out. Now, this one right here is the same idea, where you could have a positive or a negative number, and you square it. Can you get a value that's less than 0? Can a positive be less than 0? No. So this one would be no solution. Do we have any questions? No? Okay. So notice here now we're going to be solving for theta in terms of degrees. Okay? So we want to find what degrees will end up making true solutions. This is where our unit circle is going to come in. Okay. So we want to get sine of theta by itself. Okay? So what's the first thing I'm going to do? So think of sine of theta, or this is 4 sine of theta, sine squared of theta. We want to get this by itself, okay? What would I do to get rid of that minus 3? Very good. So we have 4 sine squared theta equals 3. Okay? The next thing we want to do is eliminate the 4 in front. The 4 is multiplying to the sine squared of theta. What will I do now? Divide by 4. So now I have sine squared theta equals 3 over 4. Now, I don't want sine squared of theta, I just want sine. What will I do? Take the square root of both sides. Now, we remember that when you square this, it could be a negative and it becomes a positive, or it could be a positive and stay a positive, right? Okay, I know you guys know what I'm saying. It's just, so when you're taking the square root, you're actually getting a positive and a negative answer, right? Remember how we do the absolute value and we end up getting the positive and the negative? Okay, so what you need to remember is that when I have sine of theta, since I've taken the square root, my answer is going to be plus or minus the positive value or the negative value. Can I simplify the square root of 3? Nope, it's just the square root of 3. Can I simplify the square root of 4? Very good. Okay. So, sine can be positive or negative, root 3 over 2. Sine is dealing with which value, x or y? Y. So, we are going to take out our unit circle. Okay? In every single quadrant, you want to look for where is there a y value of root 3 over 2. Okay? So, root 3 over 2 y value is 60 degrees. So one of our answers is 60 degrees. Okay, y value of root 3 over 2. Root 3 over 2, 120. Okay, down here, y value of root 3 over 2 is 240. And then the last one, the y value of root 3 over 2 is 300. And again, I was looking at all the positives and the negatives because it could be positive or negative based on my answer. And so those 4 answers are my solutions. Questions? Okay, so next problem here to the right, we're trying to get this by itself. What will I do? Very good. Add 5 to both sides. So I have 10 cosine of theta equals 5. Next, what will I do? Very good. Divide by 10 is correct. So on this one, I just have cosine of theta equals, and 5 over 10 reduces to what? 1/2. Now this time, cosine is positive. Which quadrants is cosine positive in? Very good. So I'm looking in quadrants 1 and quadrants 4 for cosine of 1/2. And we know that cosine is dealing with the x value. So in quadrant 1, what degree has an x value of 1/2? 60. Okay, and in quadrant 4, which one has an x value of 1/2? 300. And that's my answer. Okay? All right, so we're going to do another one. Okay, again, I like to highlight these to help me see what I'm trying to get by itself. What will be the first step on this one? Very good. Add 6. So now I have 2 tangent squared theta equals 6. Next I'll do what? Divide by 2. So I have tangent squared of theta equals 3. Now because it's tangent squared, we need to do what? Very good. Take the square root. Okay, because I'm taking the square root, we know it's going to be what? Positive or negative. Because we know inside here we could have a positive, we square it, it becomes a positive. Or inside here we could have a negative, square it, and it still becomes a positive. So it's positive, negative root 3. And we know that even though this isn't a fraction, we can make it a fraction by putting it over 1. Okay, now tangent is what? Y over x. And we're looking in every single quadrant because it's what? Positive or negative. So we're going to get 4 answers for this one. And so we're looking for what degree has the y of root 3 and the x of 1. And remember, we're not looking at denominators. 60. Do you see that? The y is root 3, the x is 1. Okay? In the next quadrant, which one has the y of root 3 and the x of 1? 120. And the next one is 240. And quadrant 4 is 300. Okay. On this one, do you see how these are like factored? They've actually made this very nice for you. All we're going to do is take each of these factors and set them equal to 0 and solve. So this one actually has 2 problems in one. Does that make sense? Okay, so I'm just going to kind of draw a line right here, and I'm going to separate 2 problems. We have root 2 cosine theta plus 1 equals 0. And then we also have 2 sine of theta minus 1 equals 0. And there it is. Okay, so here we're trying to get this one by itself, and we're trying to get that one by itself. What will I do first on the first? Very good, subtract 1. Root 2 cosine theta equals negative 1. Next, what will I do? Very good. Divide by root 2 to both sides. So now I have cosine theta equals negative 1 over root 2. Is that an appropriate answer? No. Nope. What do we do? Very good. Rationalize the denominator, and we end up with negative root 2 over 2. Okay, so cosine is dealing with what? X or y? X. Okay, and specifically our value is negative. The x value is negative, and so where is cosine negative? Okay, I'm going to say quadrant 3 and quadrant 4, correct? And so, yeah, where is the x value? Negative root 2 over 2, and we can see right here the x value is negative root 2 over 2 at 135 degrees. Yes, yes, you're right. 2 and 3, thank you. Are you still confused? Okay, so that was quadrant 2. Now we're in quadrant 3. Which x is negative root 2 over 2? 225. Okay, so I'm going to give you about a minute. Solve this one on your own. Get the 2 degrees. Anybody have the answers yet? Oh, yes, there's only 2 answers for that one. Yep.
So sine is negative. Sine should be
Okay, so majority of you guys got it right. The correct answers were 30 and 150 degrees, in case I didn't check yours. My first step here is to do what? Add 1. So I have 2 sine theta equals 1. Next I will do what? Divide by 2. Sine of theta equals a positive 1/2. Now this is how you can kind of always double check that you have things right, but we know that sine is positive in which quadrants? Quadrant 1 and quadrant 2. And so we're looking for the y value of 1/2 in quadrant 1 and 2. So y value of 1/2 in quadrant 1 is 30 degrees, and over here y value of positive 1/2 is 150. See how the y value is 1/2 at 150. Okay, 30 degrees, 150. Yes?
Well, I got this one, but on the last problem, what did 332? Well, not 332, but like 330 also for an answer.
So we're looking for the x value at negative root 2 over 2.
No, not that one. The other example. That one. With
I don't-
tangent.
The one with tangent?
Yeah, our answer. Wouldn't it also be 330?
Okay, so we're doing y over x. So y is 1. That would be 1 over root 3. Okay? And you're only going to get 1 degree per quadrant. Okay? All right. Any other questions? Okay. Go ahead and turn the page. Okay, a couple more examples. Okay, so again, on this one, we're trying to get 6 tangent of theta by itself. Okay, and so what will I do first? Thank you. Good. Subtract 2 root 3. 6 tangent of theta equals negative 2 root 3. Next, what will I do? Very good. Divide by 6. And so I have tangent of theta equals, and what does it reduce to? Negative root 3 over 3. Okay. So this is our y over x, and tangent is negative in which quadrants? Tangent, and you, which quadrants is? Okay, 2 and 4. All right, I just heard a lot of answers. I know some of you said it right, but quadrant 2 and quadrant 4. Okay, so when we go to quadrant 2 and we're looking for a y over an x like this, is there anything that has a root 3 and a 3? No. So what am I going to have to do on this one? It's not no solution. Wouldn't that be nice? Guess. Okay, that is an option. I would say that's not the best option. You're going to, basically, with tangents, we have to unrationalize the denominator. So what do I mean by that? I'm going to take negative root 3 over 3, and I'm going to multiply by root 3 over root 3. And when I do that, I end up getting, on the top, it's what? negative 3, and the denominator I have 3 root 3, and then what happens? These cancel out, and you get negative 1 over root 3, okay? Y over x. So now let's go back to quadrant 2, and is there a y value of negative 1, and or really the negative, it doesn't matter which one it's with, but a y value of your 1 and the x with root 3? Which one? 150 is correct. Okay? And then in quadrant 2 again, we're looking for a y with 1 and an x with, or no, did I say quadrant 2? I meant quadrant 4 now. A y again of 1 and an x with root 3. Very good. Okay. Yes?
If we're looking for a fraction for tangent, can we just look across the line itself? The line that bisects the circle.
Show me later. Okay? Because I'm not quite sure, but I'm sure you're right. Okay. Oh, I see what you're saying, like diagonal from it. Yes, you were right. So, what he was saying right there, it's just the line that's diagonal. So they are like connected for tangent. Do you guys see that? 150 and 330. Okay, got it. All right. Here we go. What do I do first? Very good. Subtract root 2. Okay, this cancels. 2 sine theta equals negative root 2. What's next? Very good. Divide by 2. Okay, so I have sine of theta equals negative root 2 over 2. Sine is dealing with our y value. And which quadrants will I look in for when y or sine is negative?
3 and 4.
Quadrant 3 and quadrant 4. I agree. So we're going to go look for a y value in quadrant 3. Do you guys agree? Sorry, put that up there. 225. And then what about in quadrant 4? Very good. So we are just looking for the y value. That is our root 2 over 2. Okay? Do we have any questions? Okay? Last one. Okay. Cosine C equals 12 over 13. Okay? It says then find the perimeter and the area for this triangle. So this is a review from problems we've already done. When we are dealing with cosine and sine and all that stuff, you need to always have what type of triangle? A 90-degree triangle. Okay? So I can make 2 separate 90-degree triangles. And because I am bisecting this, I'm cutting this in half, which makes each of those sides what? 24. Which for some reason, okay, let's try this. Let's see what happens. I feel like some numbers might be wrong for some reason.
No, the whole length.
This whole length was 48, and so if we split those, each of those would be 24, correct?
Yeah.
Okay, here is C. Cosine of C, it's saying is, cosine is what?
Oh, yeah, it makes sense.
Adjacent over hypotenuse, which means that I think this 48 was actually an error. So let's just cross all those numbers out. Okay, so are we good? Yes? So if adjacent over hypotenuse is 12 over 13, what could I write anywhere here? Cosine is adjacent. Hypotenuse is 13. And could we find that missing length? Yes. How do we find it? Oh, good. Okay. So maybe. We're just going to go with it this way. Okay, so a squared plus b squared equals c squared. A squared plus 144 equals 169. We subtract 144 to both sides. A squared equals 25, which means that a equals 5. Okay. Now, if you're doing the perimeter, if this side is 13 and it's an isosceles triangle, and we know that this side is 13, and we know that this right here is 12, and so the perimeter of this triangle, when we add around all the sides, what does it equal? It would be 13 plus 13 plus 12, and 12 is 24. Okay, and then if we're doing this in our head, we really have 26 plus 24, which equals 50, and I'm just going to call that 50 units, because when we're dealing with lengths, we should have units. Area. How do I find the area of a triangle? Very good. 1/2 base times height. Okay, or some of you might know it as base times height divided by 2, means the same thing. My base is 24. My height is 5 divided by 2. For me, so that I can just do this in my head, I reduce the 2 and the 24, which makes 12. And 12 times 5 is 60 units squared. Any questions?